Hey guys, welcome to the channel, and in this video I'm gonna be walking you guys through how to configure FreqAI um, trading system here, and also explain it to you like what's the training features we are going to the system we are giving to the system, and also what prediction we get return. So okay, let's start with the configuration here. So FreqAI is configured through the typical FreqTrade config file and the standard FreqTrade strategy. Now, the examples of FreqAI config and strategy files can be found at config examples, config freqai.example.json, and strategy is at this path. Okay. So now what I have done here is I have actually opened the strategy here. It's the hybrid one, and let me just show you this config file. Okay, so config freqai.examples, it's all the it's same as the previous FreqTrade till this point, and then we have a separate dictionary for our FreqAI. So this configuration basically tells us that whether we want it to be whether we want our FreqAI to be enabled or not, whether we want to purge our old models, train period days and backtest period days, live train retrain hours, and pass the unique ID for our models, and then to which time frame we wanna train our data. So looking at fractal nature, we have 1 minute, 3 minute, 5 minute, 15 minutes, 1 hour. So we want to capture most of the you know um, information by using multiple time frames: 3 minutes, 15 minutes, 1 hour. So it's basically an evolution of market in different time frame, meaning different granularity, if you will. Okay, now we can also use correlation fairly, which we know that Bitcoin and Ethereum are the market leaders in cryptocurrency, and when Bitcoin goes up, most of the coin goes up. When Bitcoin goes down, most of the coin goes down. Then so that's what's known as correlation. They are basically correlated to each other. Okay, now we have a label periods candles. Okay, then we have include shifted candles, which we can say that include a shift of 2. Okay, I'm gonna explain it to you guys later. Okay, then we have this, I'm just walking you guys through so that you can know what's, at least keep in your mind that what are these parameters and all. Okay, now we have DI threshold, which is dissimilarity index, weight factor, and whether we want to use principal component analysis for dimensionality reduction, which we're going to cover later. And then we can use SVM to remove outliers. Okay, here we have set true because we don't want some outliers in our training data. Then we have indicator periods candles, is 10 at 20. We're gonna look into this, okay, shortly, and whether we want to plot importance, feature importances. And then this is quite important as well, data split parameters. We want our test size to be 33% and training size will be 77%. Okay, 67%. Okay, so that's our train and test split, and then we set random state. If you know about even little bit of machine learning, you guys can understand these terms. But even if you don't, fine, because at the end of the day we're gonna be just writing maybe 20 100 lines of codes in Python and then just deploying it, okay, which are basically features. All everything else is taken care by FreqTrade, so not a problem. Okay, I think it's a solution. So um, then we have model training parameters and estimators to be 1000. Okay, and yeah, okay. Now yeah, so we have discussed this. Okay, now here's the full example. Here we have discussed here. Now um, how do we go about and build an FreqAI strategy? Well, the FreqAI strategy requires including following lines of code in a standard FreqAI strategy. So what are the like required code here is, well, we got a first no we got a first see this see here like reading these comments is very important. Okay, so see, user should define the maximum startup candle count, the largest number of candles passed by any single indicator. Okay, so we can, you know, set up to 20, 50, 100, whatever we want. Okay, now we have our populate indicators from our standard FreqTrade strategy, where we want to write this code, which is very important. This line of code is which that's the one which is going to like train our model. Okay, and yeah, okay, so see here, the model will return all labels created by user in populate and indicators and appended targets, indication of whether or not the prediction should be accepted, the target mean standard deviation values for each of the labels created by user in populate and indicators for each training period. Okay, it's too much, right? So let's simplify it. Okay, so it's saying that model will return all labels created by user in populate any indicators. So here, so let's actually they are referencing to this one, and that's why we are getting confused here. So this is the function where we want to give as much data as we want to our machine learning model. Okay, so here you can see the function description is that function designed to automatically generate, name and merge features from user indicated time frames in the configuration file, right? See these time frames. Okay, um, user controls the indicators passed to the training or prediction by prepending indicators with this, which is for training, and point C convention below, that is user should not prepend any supporting matrices, that is like bb lower band below with percent, unless they explicitly want to pass that metric to the model. Okay, so any column name which is started with this abbreviation is our training set, training feature. All right, now what we are doing here is, let me just explain the code to you, so that you know, once we like start writing the code, you guys can understand. Okay, now here we have our, we are splitting the pair. Basically it will be like btc usdt. So what we want to do, we want to use Python function and split it with this, and we want our first location here, this btc usdt, that's our coin btc only. And then we are checking if informative pair is none, which is this. What we are doing is that we want to get our informative pair. Okay, self.dp.get pair data frame, and then we are passing our pair and time frame here. Okay, now the first loop is automatically duplicating indicators for time periods. For this time periods, 3 minutes, 15 minutes, 1 hour, we are automatically, you know, populating all the features, all the indicators for that particular time period. So what we are doing is we are converting those like indicator periods candles. Okay, so we are getting this this indicator periods candle here, right? So we want to do it for last 10 periods and 20 periods, and what we are doing is we are getting RSI for last 10 period first, and then a money flow index for last 10 period, and then ADX for last 10 periods. And then what we are doing, first it will be 10 and then 20. So we are done for 10, so we have now 3 features, right? And then we'll do this, loop this again for 20 periods, then we will have 3 more features again, and we'll have total 6 features now. Now what we are doing here is that we are getting all the indicators where the informative column is starts with this, and that's what we are discussing here. It must start with percentage, okay, because we have to differentiate between prediction, features, labels, and all sorts of stuff. Okay, so like then this loop duplicates and shifts all indicators. Okay, now this loop duplicates and shifts all indicators to add a sense of recency. And what we had told it to do is that use this shifted, include shifted candles for 2, and that's what we are doing here. So for n in range, FreqAI feature parameters include shifted candles. From here we are taking 2 plus 1, and what we are doing is it will give us a range of 0, 1 and 2, right? Okay, and then if it is 0, because 0 would be the first candle, we just want to continue and go to the next value, which is 1. Then we are shifting it for our indicators here. Okay, all right, and then we are taking it as indicator shift. Okay, so like we are here indicators, there are 6 columns here. Okay, so we are shifting all those 6 columns with 1. So if you don't know what shift, so suppose if you have data 1, 2, 3, 4, and when you perform a shift operation, a shift, this would be NaN 1, or basically this will be 1, this will be 2, and this will be 3. Okay, so we have shifted 4 here, discarded it, and like just shifted 1 step. Okay, and here we don't have this length, so that's counted as n. Okay, so that's what we have done here, shift operation. And so we're doing the shift and then adding the suffix to all those columns, shift strin. And then what we are doing is we are concatenating to our existing data frame here, informative, and adding to that informative shift. So here we had 1, 2, here we had 6 features. Now 6 is added into this much times plus this much times 6, so 12. So 12 plus 6 would be 18 features now. Okay, we have total 18 features. Okay, 18 features. Okay, now what we do is we merge those informative pair with df informative. So this informative pair is just the this for 3 minutes, 15 minutes, 1 hour. We want to do all this work. Okay, we want to do all this work for 3, 15 and 1 hour. And when you do that, what you had 18 features for only 3 minutes. Now you have 18 into 3, because you have 3 time frames, so it would be 54 features. Okay, now we have total 54 features. And let's move on and see what we have here. Okay, so we had merged our data set here with informative pair, and this will be our 3-minute data frame. This will be our all the include time frame, so we can basically add other time frame as well if we like. So we can add here 5-minute if we want. Okay, and so it will take 3 minutes as a separate, 15 minutes separate, 1 hour separate, and then 5 minutes. Okay, so we will have like 18 into 4 features. Okay, now so we add those informative pairs, we take the time frame. See here, time, we are taking the time frame, and then this is our TF here, okay, which is I think this, and then we are filling it forward. Okay, so that there's no NaN value. Okay, now we are skipping our columns here. Which column? That in standard columns, which basically like if you have these, it's basically like you can't make an adjustment, a good adjustment to your model. Although you can train a system only just use these features, but it's good not to. Okay, because we want to give machine learning system something which it completely don't understand, and then it learns from it, and that turns out to be the best approach. Okay, so we are skipping date, open, high, low, close, and volume, and then we are dropping those columns. Okay, so we will have only features, right? I mean, features meaning column starts with this, and then this is quite important here. So we have add generalized indicators here. Okay, because in live it will call this function to populate indicators. Okay, during training, notice how we ensure not to add them multiple times. Okay, so it's saying is that, you know, while in live condition it will call this. So if we had set generalized indicators, it will go ahead and, you know, do the prediction here, and add those prediction to this column, so that we can use it in our populate trend, populate entry, or populate exit. Okay, now what we are doing here is that, so user adds targets here by prepending them with ampersand here. See convention below. If user wishes to use multiple targets, a multi-output prediction model needs to be used, such as templates, cat boost prediction, multimodal, or pi. So what's happening here is that we are shifting our close to how much far in the future we want to see our prediction. So this is label period candles, right? So if we can find here label candle period. So what we are doing is, suppose you have 1 2 3 4 5 6, and you want to predict the next 4, 1 2 3 4, right? So initially what, so yeah, so what you do is, well, right now you have this, okay, and you want to predict this. So what we can do is, we can populate this with 1 2 3 4 5 6, 1 2 3 4, and extend this, okay, to our prediction. Okay, so here what we are doing is, see, we are shifting it minus means like in the first +1, what we are doing is we were shifting like this, right? So 1 will be here, 2 will be here, 3 will be here. Now we are going backwards. What we are doing is, we are going backwards and shifting upwards. So 1, this one, this one. So this sequence would look like 2 3 4, and here will be NaN. As in this case, the NaN was here, right? Now the NaN is here. So what it says is that now we have 20, right here. Go back to 20 candles prediction. So we are shifting our close to -20, 20 shift. So you can imagine, if the close is, this is close, then shift it to 20 and populate this to NaN, so that we can fill some values here. Now rolling is that it's like doing smoothing smoothing basically, and then mean. So it's just like for up to 20 candles it will sum them up, then from here it will start and sum them up 20, next 20. So you can see like it's summing them up and taking a mean of it and also dividing it by close, that current close of. So it's basically a technical analysis uh, trick if you like. So it's basically smoothing the close price so that there's no whipsaw or spikes in the signal, right? Which is as close. And what we are doing is that we are basically converting it to 0 to 1, right? And we are taking minus of it. Okay, so yeah, that's our S close. Then we are returning the data frame, which is very important so that we can use it in our populate entry trend and exit trend. Now what we're gonna do is notice how the populate and indicators is where features and labels targets are added. Full example strategy is available in FreqAI example strategy 5. So let's go ahead and see what example they have here. So here I'm looking at the example FreqTrade has suggested me. So this is our example file, and see what it says is the example strategy showing how the user connects their own FreqAI model to the strategy. Namely, the user uses self.freqai.start data frame metadata to make predictions on their data. Populate and indicators automatically generates the variety of features indicated by the user in the canonical FreqTrade configuration file under config FreqAI, which we have already looked at. Okay? So here are some standard FreqTrade stuff. Okay, we are setting can it sort or not. Well, in this case it can't. And then this is our populate and indicators, which we just looked here. Okay, here we are doing the same stuff here. See, getting coin informative pairs and then populating those features, right, for different indicator pairs candles, and we are populating a lot of features. Okay, so after that what we are seeing here is that we had added that shift parameters, and we are also adding some percentage change feature here because we want to drop those raw features. So here we are adding percentage change and raw volume is very important, and raw price as also is close price. Okay, well, see, this is where the art in machine learning comes in. Okay, what you wanna like do is like you should be able to like interpret like which indicators or which technical analysis tool will aid the most productive performance in my system. Okay, because there are millions of ways to define a trend, define a like whether the market is in overbought or oversold condition, whether the market is in a momentum using ADX, whether it's volatile. If the ATR is increasing, then the market is volatile. Like Bollinger Band, you can technically most of the time you can like estimate like where the market is going to stop and turn around. So that's all the features we are using. Okay, and volume as well. So actually the volume is very fundamental to trading, and in the future we're gonna be like going deeper into volume, like how can we morph the volume into new indication of where the most buyers and sellers are present. Okay, so that's going to be interesting. All right, now uh yeah, so we are doing all the same steps here, and then we are adding a day of the week and hour of the day as well. So we can like uh machine can understand which day to trade, which day not to trade basically. Well, that's the thing, like at the time we don't know like how the machine is learning. We do have a good idea of how it's calculating. It's just matrix multiplication, linear algebra, but it in a higher order. Okay, so like we used to do matrix multiplication of 3 by 3. Okay, so it can be 3 by 4 here, but all you gotta see is the same, and then you have a matrix of 3 by 4. Okay, now in this case, as we had seen earlier, that we have a feature of around 54 features. Now assume this all columns are these features. So basically what you will have is that you have many columns here, suppose 7,000 columns, all right, and then you have all these features, 54 features, which is your technical analysis, by the way. Like, so you want to give your model, your machine learning model, a data which has potential to, like, identify those patterns. Like, it's all pattern recognition, all right. So let's go ahead. So this is also a good idea to add day of the week and hour of the day, and then we did the same thing here as we saw over there, right here. So yeah, it's the same example. And yeah, here we can add some classifiers if you'd like to. Let me just uncomment it and explain it to you guys, what it is basically. So what do we have here? Well, here you can see, like, if you want to go for classifiers, so here we were going for regressor, right? Regressor, so regressor, right, and classifiers. Regressor means simply like, suppose you have closing price here. Okay, so you have closing price of, suppose, Ethereum 1337, 1336, and then like you can go ahead 1400, like, and you want to predict the next, like what's the next 10 price gonna be. Is it gonna be upward trending or is it gonna be downward trending, so that you can like add some condition. So it's basically like identifying, okay, yeah, I see the market is gonna be trending in the future. Okay, so that's a regressor. Now the classifier is like, you are basically reducing this complexity of overfitting to a classifier where you wanna like, classify whether, if next price is less than previous price, then we can say that it is down, price has went down. Now the next price is greater than previous price, then okay, the price has went up. So we are basically giving market a model, not a number, but a classifier, which it can, like, it can do some number crunching over here with all the features it has, and then give you only two outputs, whether it's going to be up or whether it's going to be down. And that's what we are doing here. Okay, so here we want to see, here the model will, prepend all these regressor basically. So if it is greater than close, then we want to say that okay, it's up. So suppose the future, so consider this as a future candles. Okay, if the future candles are greater than current candles, okay, then it's going to be up, otherwise it's going to be go down, right? So that's our classifiers. Okay, now this is our S range. So it's for multiple targets. Okay, and what it's doing is that, well, you can see that we are taking the max of certain period and rolling and like taking the average of those and taking the max of it. So if your SMA 30 is like this, okay, and you are taking the same, so like open, high, low, close, okay, and you have, this is the SMA 30 for close, this is SMA 30 for like high, right? But as we are talking about close, let's suppose this is our trading environment and this is our SMA EMA 30 looks like, okay. Now what we are doing is, here we are taking SMA, so not, I mean, for example, okay, let's just take it example, or let me just do what it's doing, okay. So what it's doing is it's shifting backwards and then rolling to that candle, basically taking all those number of candles and taking the max out of it. So from this to this, what will the maximum points? This, okay. From this to this, what will the minimum point? This. And we are taking the difference of it, okay, the difference. See, this is our price axis, all right, this is our price axis and this is our time axis. So we are taking this difference and like okay. So we were doing, you know what, let me just draw it again, this is such an important okay. So this, from this period to this period, this is maximum, this is minimum, then we are taking the difference here, okay. So what it's saying is that for the last 20 periods, okay, what is my average rate of change, basically not average, but you can take it as average because you are taking maximum and minimum, so the difference between them would not that much differ, okay. So that's we are taking here, difference between them, and that's what shows us that volatility, basically it shows us volatility, right? How much did we change, how much did we move up, how much did we move down, and if you add volume to it, it will add more information to your, like, how the market behaved in this 20 periods going backwards. So that's our multi classifier, okay. And let me just uncomment this, I mean comment this, basically. So yeah, and now what we are doing here is that let's go ahead and see, okay. So notice how the populate, okay, yeah, we done that, and then notice also the location of the labels under if set generalized indicators at the bottom of the example. This is where single features and labels targets should be added to the feature set to avoid duplication of them from various configuration parameters that multiply the feature set, such as include time frames. So yeah, we have done that, right? We have done this, we have used this set generalized indicator, so it's easier for us, okay. Now note here is that the self.freqai.start function cannot be called outside the population indicators. We have to be called this training here, okay, this populate indicators here, okay. Now features must be defined in populate and indicators. Defining FreqAI features in populate indicators will cause the algorithm to fail, okay, in live or dry mode. In order to add generalized features that are not associated with a specific pair or time frame, the following structure inside populate and indicators should be used as exemplified in FreqTrade templates, FreqAI examples or strategy. So that's what we did here, right? This is what we are using, okay, because day of the hour of the day or day of the week is gonna be same for any time frame. All right, it's not gonna be different. Okay, that's why we are setting it only once, and that's what it's saying. Okay, so let's move on. Yeah, we have saw the example here. Okay, so we have done this. Now let's see the imported data frame key patterns. Okay, so I think it's very important. I won't take too much time. I'll just explain the certain feature over here. So, and also it's very important, so let's just go and draw this. Okay, so we have df ampersand star. It shows that it can be any data frame column prepended with ampersand in populate any indicators, is treated as a training target label inside FreqAI, typically following the naming convention and -s star. For example, to predict the close, because see, we had done here the same. Okay, here, right? See this ampersand -s and then close. Okay, now for example, to predict the close price 40 candles into the future. Okay, here minus, suppose here is 40 minus 40, we are predicting 40 candles into the future. 40 candles future. Okay, future, you would set df ampersand as close equals to df close shift minus this cell dot FreqAI info feature parameters label period candles with label period candles set as 40. Okay, so I think it would be easier to show you guys that here, see, label period candles, and let's just for the sake of example change it to so we have done that, and let's move back to the strategy, and let's check it out here. Okay, so in the config FreqAI, okay, so we have done that in the config, and now FreqAI makes the prediction and gives them back under the same key here to be used in populate, entry or exit trend. Okay, so what we do here, right, we had like 40 unfilled in the future. Okay, after training it here, okay, after training it will make predictions, and all those outputs, these 40 candles will be filled at this point in time, and you can use it in populate entry and exit trend. Okay, so now let's move on. So we have ampersand standard deviation mean. So this is a standard deviation and mean values of the defined labels during training or live back testing with fit live predictions candles. Okay, commonly used to understand the rarity of a prediction. Use the z-score as shown in templates FreqAI strategy.py and explained here to evaluate how often a particular prediction was observed during training or historically with fit live predictions candles. Okay, so see here we have done this standard deviation multiplier by range, and then we are multiplying it to that standard deviation and adding to the mean. So what we are doing is that those let me just show you first. See, we have this multiplier, right, categorical parameter, so this standard deviation, and what we are trying to solve here is that we are assuming that market are follow this any distribution follows this bell curve, right? And now as we have our mean here, right, what we want to do is we want to add this standard deviation as well. Okay, so we want as much area as possible for our prediction to fit in. So okay, can also reduce the noise if you will. Okay, so now we move on to um, our do predict. So what does do predict does is that what is do predict column is, it is an indication of an outlier data point. The return value is higher between -2 and 2, which lets you know if the prediction is trustworthy, okay, or not. Do predict equals to 1 means that the prediction is trustworthy, okay. If the dissimilarity index DIC details here of the input data point is above the threshold defined in config, right? So let's go to the config and see it. Okay, we have config here and our dissimilarity index around here. See this. So what they are saying is so if the dissimilarity index of the input data point is above the threshold defined in the config, FreqAI will subtract 1 from do predict, resulting in do predict equals to 0. So it's basically a stability in the prediction and training, right, input data and all. So if use SVM to remove outliers is active, which in this case yes it is, the support vector machine may also detect outliers in training and prediction data. Okay, in this case the SVM will also subtract 1 from do predict. So let me just explain it to you in a more intuitive way. So SVM is basically, suppose you have these points over here, okay, these data points, okay, and some data points are here. So when you use regressor, you can just draw a line and say that okay, it best fits my model. Now when you have SVM, you go ahead and draw a parallel line, basically, you know, taking I'm basically simplifying it for a larger audience, but yeah, it's just simplification, man. All right, at the end of the day, what you'll be getting is that this distribution over here, okay, where like we want this data to be around this 68% or 65% interval on this um, standard deviation, and that's why like we were using this, here if you can see, we were using a multiple standard deviation here, not just 1 to a whole number, but we are basically using 0.75, 1, 1.25, 1.5, 1.75. We weren't even going to 2. Okay, so we are basically, because 2 standard deviation is where the 90% of 95% of the data lies, but in the actual world what the data really looks like is something like this. Okay, so it might look like this, something might look like this shifted there, some data might look like even this, right? And what it will do, this SVM, is that it will adjust it to our live training environment. Okay, so it will like converge, basically our training data will converge to the solution point around here, which is our like around, I think we are estimating around 80% of the data points. Okay, because seeing this standard deviation multiplier, it's around 1.75, so I can estimate it's around 80% distribution here. Okay, distribution around mean. So yeah, I think it's quite easier to understand it this way. Okay, so all right, so it may also detect outliers in training and prediction data. In this case, the SVM will also subtract 1 from do predict if the input data point was considered an outlier by the SVM but not by the DI, or vice versa. The result will be do predict equals to 0. So it's basically saying that we have a fail safe here. Okay, if DI doesn't work, then SVM will work. or if SVM doesn't work, then DI will work, or if both of them doesn't work, then we already have a failsafe of 0 where do predict will be 0. And if like they estimate both of them depending on the current distribution of the prediction we are getting is within the like range, then it will the do predict will be 1, and that's where we place our trade, right? Now if both the DI and SVM considers the input data point to be an outlier, the result will be do predict equals to -1. See, that's what I was talking about. So it's like it's just assigning -1, which in this case it's saying is that this is the worst outlier and it should be like discarded, okay, which is -1. As with the SVM, if use dbScan to remove outliers is active, dbScan may also detect outliers and subtract from do predict. Hence, if both the SVM and dbScan are active and identify a data point that was above the DI threshold as an outlier, the result will be do predict equals to -2 here, okay. So a particular case is when do predict equals to 2, which means the model has expired due to the exceeding expired hours. Okay, so what it means is that we only want to focus on, because most of this stuff is taken care by FreqAI, so we will only want to focus on 1 and 2. 1 is for entering the trade, and 2 is for like and if you wanna a risk management, basically saying that number of hours you wanna like let the trade active for certain number of hours, and that's where it comes, okay. Now we have DI values. So dissimilarity index values are proxies for the level of confidence in FreqAI has in the prediction, okay. Now a lower DI means the prediction is close to the training data, and the higher prediction confidence is, yeah, okay. So it's basically saying is that lower value of DIs it will be close to the training data, and also it will have a high prediction confidence, okay. Now we have this percentage star here. Anything, you can put any name here, but you just got to start with a percentage over here. Now this can be any data frame column prepended with percentage in populate and indicators is treated as a training feature. For example, you can include the RSI in the training feature set, similarly to in this example over here by setting DF percentage RSI, okay. So yeah, we have done the same here, right? Here we have added RSI with this suffix, okay, this prefix, basically percentage, okay. That's how the machine learning model knows that it's a training data set, okay. Note, since the number of features prepended with percentage can multiply very quickly, tens of thousands of features are easily engineered, okay, using the multiplicative functionality of, that is, include shifted candles and include data frames as described in parameter table. That's what we did here, right? Here we saw that like from 18 it's just spiked to 54 because we had 3 time frame, and then we had like shifted those to 2 of that, then it would be 54 times 2, right? And yeah, so okay, so see the number multiplied by 2, so it has this exponential property to this feature engineering over here, and we can, like, you know, scale it to tens and thousands of features very easily, okay. Now these features are removed from the data frame, that is returned from FreqAI to the strategy to keep a particular type of feature for plotting purposes. You would prepend it with percentage, Okay, so this is interesting here. Okay, so suppose, because from the experience I know that RSI works great. Okay, they haven't included ATR, but ATR also works great. Okay, now what I can do is I can add all the features that I know is interesting for me and prepend them to um, double percentage, so that I can plot a feature importance. In machine learning term, what we say is that we want to learn something from this feature, right? And if we can quantify it uh, by visually graphic way, in a graphics way, we can see how much that feature contribute to the prediction, uh, and basically how it improves the confidence in prediction. Okay, so that's about it. Right now let's go ahead and see what we have here. Okay, now we have setting the startup candle count. Okay, so what it does is that the startup candle count in the FreqAI strategy needs to be set up in the same way as in standard FreqTrade strategy. See details here. Now this value is used by FreqTrade to ensure that a sufficient amount of data is provided when calling the data provider. To avoid any NaNs at the beginning of the first training, you can easily set this value by identifying the longest period in the candle units, which is passed to the indicator creation functions, that is TLE function. In the presented example, the startup candle count is 20, since this is the maximum value in indicators periods candle. Okay, so what we are referring to is that suppose you want to add 200 some simple moving average, so you want this to be, at least we should have 200 candles in order to calculate the moving average of last 200 candles, right? So that's what it's saying here. Okay, now note here that there are instances where the TLA functions actually require more data than just the past period, or else the future data set gets populated with NaN's value. Anecdotally, multiplying the startup candle count by 2 always leads to a fully NaN free training data set. Hence, it is typically safest way to multiply the expected candle startup count by 2. Look out for this log message to confirm that the data is clean, right? So in our previous videos I had said that like this is very important message. So it's showing that we haven't dropped any training data set because there was no NaNs values in this much length of training data set. Okay, so let's go ahead and see what we have here. We have a creating a dynamic target threshold. So what it does is deciding when to enter or exit a trade can be done in a dynamic way to reflect current market conditions. FreqAI allows you to return additional information from the training of a model. More information can be found here, and for example, ampersand star standard mean returns values describe the statistical distribution of the target or label during the most recent training. Comparing a given prediction to these values allows you to know the rarity of the prediction. In templates FreqAI example strategy.py, the target ROI and cell ROI are defined to be 1.25 G scores away from the mean, which causes predictions that are closer to the mean to be filtered out. Okay, so it's basically saying is that so like if you know about Bollinger Bands, okay, so suppose the price is like, you know, trading sideways for a couple of while, and then we see some huge spikes, meaning we saw some moment in the market. Okay, so what it's saying is that if this is our standard deviation of 1, okay, 1 multiplier, and this can be between 1.25, okay, from here to here, right? So that's what we want. We want to be in the market where the market condition is good. It's flourishing, okay, and that's where we want to be, and that's what this calculation is all about. We are basically getting a range of like sell and target. So we are multiplying the standard deviation. So if you have a SMA here and you go here this up direction plus 1.25 and you go down direction minus 1.25, you have another line built here. What you can do is, if you are if you are buying here, you can sell here, right? But we don't want to buy here, we want to buy here. We can sell there, right? We want to sell there and then we want to buy here, meaning like we want to go long here, we taking this much profit, and then here we want to go short, taking this much profit. Okay, so that's what we are doing here. Okay, so let's see what we have next. So consider the population of historical predictions for creating the dynamic target instead of information from the training data as discussed above. You would set fit live predictions candles in the config to the number of historical prediction candles you wish to use to generate target statistics. So here what we are, so see here, all this is basically a prediction. Okay, we are getting this let me check. Okay. Yeah, that's what we are doing here, right? Target ROI and sell ROI. So it says that the model will return all labels created by user in this, appended this, an indication of whether or not prediction should be accepted. The target, mean or standard values for each of the labels created by user in this for each training period. Okay, so what we are seeing here is that see here, okay, we have as close. Okay, after we do the training, that in the data frame we will already have these columns. Okay, mean and standard deviation of the predicted close price. Okay, here, and what we want to do is we want to get the upper level of it, which is target, and lower level of it, which is sell ROI, and that's where we want to execute our exit our trade. Okay, or enter our trade, it depends on how you look into it. Okay, so we can set this to fit live predictions candles for 300. Okay, and then if this value is set, FreqAI will initially use the predictions from the training data and subsequently begin introducing real prediction data as it is generated. FreqAI will save this historical data to be reloaded if you stop and restart a model with the same identifier. So that's pretty useful. Okay, now using different prediction models, FreqAI has multiple example prediction model libraries that are ready to be used as is via the flag FreqAI model. These libraries include CatBoost, LightGBM, and XGBoost, regression, classification, and multi-target models, and can be found in FreqAI prediction model. So we have seen this in the introduction to AI video. Okay, and if you wanna like let me just show you. So here if you go to FreqAI, okay, FreqAI, and go to the models here, prediction models, you're gonna see all these models. CatBoost classifier, we are using CatBoost here, CatBoost regressor multi-target, LightGBM classifier, right, LightGBM regressor, see all this. Okay, now what it's saying next is, now the regression and classification models differ in what targets they predict. A regression model will predict a target of continuous values. So that's what I had explained, right? we want to predict the target of continuous value here, whether it is going up or not. So this is our training data, and this will be our prediction data. So it will basically forecast what's gonna happen in the future. Okay, and so for example, what will the price of BTC will be tomorrow, whilst a classifier will predict a target of discrete values. For example, if the price of BTC will go up tomorrow or not, this means that you have to specify your targets differently depending on which model type you are using. So we have I have already explained it to you guys. For like regression, we want this continuous data. It can be like close price, anything. Like for classifier, what you need is 1 or 0, up or down, right? You can add up, down, or sideways market, so that you only want to enter long on up market, only want to enter short on down market, and do nothing on sideways market. So yeah, right. Now all of the aforementioned model libraries implement gradient boosted decision tree algorithm. Okay, now they all work on the principle of ensemble learning. Okay, so this is where it gets pretty tricky. Okay, so technically you don't have to know how this works. Basically, ensemble learning, gradient boosting, decision tree algorithms, because well, this was the like motivation of FreqTrade to basically abstract this machine learning, deep learning models in such a way that we only pass our training data. Okay, and that's what we're doing. So it certainly helps to understand like what's going on underneath the hood. So let's continue. All right, now where predictions from multiple simple learners are combined to get a final prediction that is more stable and generalized. The simple learners in this case are decision trees. Gradient boosting refers to the method of learning where each simple learner is built in sequence. The subsequent learner is used to improve on the error from the previous learner. If you want to learn more about the different model libraries, you can find the information in their respective docs, okay, which is CatBoost, LightGBM, XGBoost. Okay, now there are also numerous online articles describing and comparing the algorithms. Some relatively lightweight examples would be CatBoost versus LightGBM versus XGBoost. What is the best, which is the best algorithm, and XGBoost, LightGBM, or CatBoost, which boosting algorithm should I use? Keep in mind that the performance of each model is highly dependent on the application, and so any reported metrics might not be true for your particular use of the model. Now, apart from the models already available in FreqAI, it is also possible to customize and create your own prediction models using the iFreqAI model class. You are encouraged to inherit fit method, train method, and predict method to customize various aspects of the training procedures. All right, now you can place custom FreqAI models in user data FreqAI models, and FreqAI will pick them up from there based on the provided FreqAI model flag name, right, which has to correspond to the class name of your custom model. Make sure to use unique names to avoid overriding built-in models. All right, so what it's saying is that we can potentially create a custom model here, and we can uh, deploy it as well. It's very easy. We just have to give it a unique name and pass it after this flag FreqAI model. Okay, now let me just show you the example as well, because I think it would make a lot more sense if I just show you the here. And yeah, when you go to user data, you have these FreqAI models, right? At the moment it's completely empty, but if when you create it, you can give that unique name, you give that model, right? So yeah, now here are some guidelines on how to set targets here. So setting model targets for regressors, if you are going to using a regressor, you need to specify a target that has continuous values. Okay, FreqAI includes a variety of regressors such as the cat boost regressor via the flag FreqAI model cat boost regressor. An example of how you could set a regression target for predicting the price 100 candles into the future would be like this. Okay, you would be doing this. All right, now if you want to predict multiple targets, you need to define multiple labels using the same syntax as above. Okay, now for classifiers, if you're using a classifier, you need to specify a target that has discrete values. Okay, now FreqAI includes a variety of classifiers such as the cat boost classifier via the flag FreqAI model cat boost classifier. Okay, now if you elect to use a classifier, the classes need to be set using strings. For example, if you want to predict if the price 100 candles into the future goes up or down, you would set like this, which I had already explained here, right? Up or down. Okay, so that's what we want to do there. And then if you want to predict multiple targets, you must specify all labels in the same label column. You could, for example, add the label same to define where the price was unchanged by setting. Okay, so here we are doing the first step here to label, and then we are seeing if both are equal in the future, then we are saying same, and yeah, we are passing the previous value from here, right? So the important thing is that we have one column here. Okay, so that we can populate any category we want, 1 2 3 4, and if 1 is there, then go with this direction, 1 2 is there, go with this direction, 3 is there, then stay with this, if 4 is there, right? Suppose you have some volatility contraction pattern here, okay, where market just goes here and there, and you really don't want to be in the market, so you can have a new label here, like calculating a different way of calculating this. So it would be like, if this is greater, so you can put ATR here. Okay, so if close is between certain ATR value, then you can say, okay, yeah, market is volatile, so okay, we won't be entering trade. So at this moment, our labels for categorical features, the classifiers would be up, down, same, same, and volatile. Okay, it depends on like how do you like, yeah, it depends on your use case basically, like how you want to approach the market. Okay, so I think that's all about the configuration. We have like covered a lot here. So this is basically a fundamental base for our future direction in using FreqAI. And in the next video, I'm gonna be like going through implementing this system here, and basically showing you how to do it in a like a professional way, if you like, because well, FreqTrade has made a lot of things easier. And you know what, let me just, yeah, I think I'll show you guys in the next video. Okay, and for the sake of it, let's just train the model and see. Okay, so in order to train the model, what we do is we do this. Okay, so we can go to our hybrid and take this example. Okay, so what we want to do is we want to run FreqTrade back testing, and we want to pass our strategy to FreqAI example strategy. All right, okay, so it is example strategy, and strategy path is going to be user data. Okay, it's FreqTrade. All right, and then templates, where is it, let me see. Okay, so we have templates. Okay, so let me just start it again. We have quick trade back testing strategy is gonna be our this strategy here. Copy, paste it here, and then strategy path is gonna be um, here, right? So we are at the money farming directory over here. Then we wanna go to quick trade, then again go to quick trade, then go to templates, and then that's our path, right? Right, and then what we want is config file, right? So config is basically is around here, right? Config example. Now, so config, what we gotta do is we gotta pass um, okay. Now config is going to be um, quick trade config examples, and we want config FreqAI dot example, right? That's our config file, and our FreqAI model would be FreqAI model is gonna be well, we are using regressor, right? So let's just use get boost regressor, and then let's see, let's set the time range to be 22 10 01. Okay, we gotta give the open end here. Okay, so 22 10 30. Strategy path has patch over there, do that. Okay, time range spelling is wrong. All right. Okay, so here it's saying that user data does not exist, right? So we can create our user data. Quick trade create user data. Okay, user, and you know what, we were actually at money farming directly, so let's go to the quick trade and run this. Now it's gonna make, now it's gonna do it well. Okay, make certain changes here. So we don't have time frame data here. Okay, so saying that main time frame of 5 minutes must be smaller or equal to fixed. Okay, I had, for example, right, I had changed it to 5 minutes, right? So let me just make it 3 minutes. See, it's actually going ahead and like seeing there is no data. Let me just download the data. Okay, trade data. We want file to examples, want our big AI example .json. I think let me just, and yeah, it's gonna download the data. Okay, we want to give time frame as well. We wanna just 3 minutes. What data frame we want? 3 minutes, 15 minutes, and 1 hour. All right, let it download. It's only gonna take, and we want 15 minutes. Because I just want to show you guys this system really works. Okay, so all this explanation is so that you guys know and you guys understand like what's going on in behind the system. Okay, what's going on underneath the hood, okay, and you can customize it to your liking. how you wanna approach them. Let's train it. Back testing. It will first test. So yeah, now we have what error we had. It actually started training, and you know what? Actually, uh, what I found out that this one is throwing that error, right? So let's try the hybrid one, okay? Because hybrid one is quite good, to be honest. So let me just paste the hybrid one. See, config.json not found. All right, give it a config examples, quick trade. Okay, is it the same example though? I think it's the same example. Yep, on this example. Okay, and so it's not picking up. So quick trade FreqAI hybrid strategy path is going to trade templates. FreqAI model is gonna be good. I have config file is gonna be AI. So see here, it has basically started this, and let me just for this configuration make some changes over here. So I'll just do 127.0 not this, and do it like this. Okay, 0.0.0 maybe 8,000. So we have that. We can leave it anything, and or we can run back testing. I think I should go for back test, but I just want to show you guys like how it works. See, we started downloading the data, right? And as in the next previous video I had shown you that like how it works basically. So I get here 1000. Here you can see it basically started training there, and can monitor it basically. Okay, this is the password here. So there we go, guys. We have our system. All right, here of that one. So we are training here, and this is the training is going on here. See, here it started training here. That's what we are. It doesn't show us that this log because happening live. Yeah, right. So I think that's it for this video, and I hope you guys like it, and let me know what you guys have recommendation for me, like if you wanna cover some some systems, different strategies, TensorFlow model, PyTorch model, or even like go ahead and understanding the like trading it live or something, just let me know. Anything comes in mind, just drop in a comment, and please make sure to like, share and subscribe so that you don't miss any new content in the future. And as we are predicting future, subscription is the insurance for predicting like when the next video is gonna come. So there's like little machine learning humor there. So anyway, I hope you guys like it, and I'll see you guys in the next video. Thank you.